we have a tricky one, and here it is. We have a piecewise function that has an absolute value in part of it for all the values of x that are not equal to 5, and for all the values of x that are equal to 5, it's equal to 9. We want to know what happens as we approach negative 5, okay, which has nothing to do with this 5. It has everything to do with things that are, well, not equal to 5. So here's the deal. We don't need this part. X approaches negative 5, so we must be dealing with the things that are not equal to 5, so we're dealing with this, okay? So as we look at this part, we realize that plugging in a negative 5 is still not going to work. We would have 0 over 0, so no, not going to happen. What I'm going to do is write this piecewise function very differently. And just going to doodle a little bit over here on the board right below it. So this, just follow me here. I'm doodling. I'll write bigger so you can see it. It doesn't look like it's showing up very well. If I had absolute value of x plus 5, and I graphed it, like if it said y equals, just on a whim, I would cross the x-axis, or touch the x-axis, at negative 5. And every absolute value is essentially a piecewise function. And the pieces are, in this case, x plus 5. And then this would be the opposite of x plus 5. And the breaking point of that is at x equals negative 5, which would be the opposite of this. Okay? Negative 5 is the issue, and that's what we're approaching. So this piecewise function can be even more piecewise-y, and here's how. The absolute value of x plus 5 over x squared minus 25 is really that, right? Yes, good. Okay, great. And what I'm dealing with is a situation where, just like you saw in that little graph that we just drew, where we really have two different types of things that are going on. We have the regular that's going on for all the values that are greater than negative 5. And I'm ignoring all the restrictions on positive 5 and the fact that it's a 9. Like, none of that is relevant right now because we're just looking to see what happens around negative 5. So for all the values of x that are greater than negative 5, we would just have that regular part. That was this part of the graph. Now we're going to deal with this part of the graph, which was the opposite of that. So we would have negative and then x plus 5, and then x plus 5, x minus 5, for all the values of x that are less than negative 5. And at negative 5, well, it just doesn't exist because you'd be dividing by 0, right? So basically, this is what I'm looking at. And I want to know what happens as I approach negative 5. So let's do a little bit more work here. Cancel, cancel, and we have 1 over x minus 5. And cancel, cancel, and we have negative 1 over x minus 5. So we're going to figure this limit out from the left and from the right. Okay, we have to approach from both sides, right? So limits is where you have to come in from the left, come in from the right, make sure they match up. And direct substitution doesn't work, so we kind of have to work through it this way. And I'm going to look at this and say, well, if I did direct substitution, like right now, if I did direct substitution and plugged in a negative 5 right here, I would have negative 1/10. Okay, and I have thrown my limit process out the window. Let's actually go back to it for a second. This is the way my work would look. The limit as x approaches negative 5, and I don't think you've seen this notation yet. I'm recording these videos out of order, so I don't remember what you've seen and what you haven't, but here goes. So just in case you need to see it. I'm approaching negative 5 from the left. And if I'm approaching it from the left, I'm going from things that are less than negative 5. So I'm going to plug it into this one. So negative 1 over x minus 5. And that's going to be negative 1 over negative 5 minus 5. That's going to give me positive 1/10. Okay? So as we approach negative 5 from the left, we get positive 1/10. If we approached negative 5 from the right, we'd be using this part of the piecewise function. And then that would give me negative 1/10. Because the limit from the left doesn't match the limit from the right, they don't exist. Okay, there was a lot in this problem that you may or may not have seen before. One of the things you may not have seen before is this little notation about coming from the left, or from the right. Another thing you may not have thought about before is the fact that absolute value really is piecewise. And another thing that you may not have thought about is the fact that in order to do this piecewise, we had to break it up into a separate piecewise. So there's a lot going on here. Don't panic about this one, just wanted you to see it.